Hello everyone and welcome back to my YouTube channel. In this video we want to solve this equation which says that x squared minus x cubed is equal to 150. How do we break down this problem? The first thing I'm going to do is to transfer this 150 to the left hand side so that the equation becomes x squared minus x raised to power 3 minus 150 is equal to 0. Now 150 itself can be broken down into 25 plus 125. So negative 150 will be negative 25 minus 125. Now let's put that all together. The equation becomes x raised to power 2 minus x raised to power 3, then minus 25 minus 125 is equal to 0. I'm going to change each of 25 and 125 to 5 squared and 5 cubed respectively. So I have negative 5 squared minus 5 cubed, so that the equation now becomes x raised to power 2 minus x raised to power 3 minus 5 squared minus 5 cubed is equal to 0. Let us rearrange or regroup this into x raised to power 2 minus 5 squared, then minus x raised to power 3 minus 5 cubed, and this is still equals to 0. The reason we have done this is so that we can factorize each of this group, this one, and then the last two. So for the first one, this is difference of two squares and can be factorized as x minus 5 times x plus 5, then minus the second one is simply, if I'm going to introduce a bracket here like this, then the sign in the middle here will definitely change to positive. Now if I'm going to work out x raised to power 3 plus 5 raised to power 3 by known identity, this will be x plus 5 times x squared minus 5x, then plus 5 squared, which will be 25. This is actually a known identity, and because that is known, I'm going to replace all of what we have in this second bracket with all of this expression on the right, and then I'll simply slot that into here as x plus 5 x squared minus 5x plus 25, and then that is equal to 0. What we see here are common terms, x minus 5, or let's say x plus 5 actually, x plus 5 here, x plus 5 here, which is common to both sides of the expression on the left hand side of this equation. So if I group that, I have x plus 5. So this implies that x plus 5 is common to x plus x minus 5, and then I have minus, and I have x squared minus 5x plus 25, and this is equal to 0. So this implies that x plus 5 into brackets x minus 5. Let's open up this bracket. So we have minus x squared plus 5x minus 25 is equal to 0. X plus 5 into brackets. This and this is 6x. I have 6x. Then minus 5 minus 25. That is minus 30. Then minus x squared is equal to 0. I'm going to arrange that in order. So this implies what we have here is x plus 5 into brackets negative x squared plus 6x, then minus 30 is equal to 0. Now this implies that x plus 5 is equal to 0, or negative x squared plus 6x minus 30 is equal to 0. From the first one, which is this guy here, we can say that x is equal to negative 5, which will give us the very first solution to our problem. Now the second solution, I'll need to multiply both sides by negative 1. So that I'll get rid of this negative here. What I'll have now will be x squared minus 6x, then plus 30 is equal to 0. So we then need to solve this quadratic equation for x. Solving this quadratic equation, we will apply the general quadratic formula, which is x equal to negative b plus or minus b squared minus 4ac, then divided by 2a. Here our a is the coefficient of x squared here, which is 1. Our b is negative 6, and our c is 30. Let's go ahead and substitute these values into this formula here. Therefore x is going to be minus 6 and plus or minus the square root of minus 6 squared minus 4 into 1 into 30, and divided by 2 into 1. So x is equal to 6 plus or minus the square root. This will be 36 minus 4 times 30 is 120, and divided by 2. Therefore x is equal to 6 plus or minus the square root of, now 36 minus 120 would give us 84. This is 84, but negative 84, then divided by 2. So because of this negative under this radical sign, this is complex roots. So we have two complex roots, which we can actually break down into x is equal to 6 plus or minus, this is 4 times 21. So I have 2 roots 21 because of the negative, so I'll put I here, then divided by 2, which is the same thing as saying 3 plus or negative roots 21i. Notice that the I is not under the radical. So if I split that into two separate answers, I'll say x1 is equal to 3 plus the square root of 21i, or the second value, let's call it x2, that will be 3 minus root 21i. So these are the two values from the quadratic equation. And remember, we got an x value initially, which is x equals to -5 here. So if you add that, that will be the third solution. So I'll say x3 is equal to -5, giving us three distinct values for the problem we started with. Thank you so much for watching. If you have enjoyed this video, kindly give it a thumbs up. Remember to subscribe to my channel if you are yet to do so, and I'll see you in my next video.